Connection established.
Planet with resource located. Remote piloting enabled. Finally, the Zest melange will be mine.
Captain's log, stardate 4723. The USS Singleton has been on a long voyage, conducting exploratory surveys of different quadrants in the outer wilds. After completing our mission, myself and the crew have been in cryostasis for the long journey home, leaving the navigating to our ship's assistant droid, K7. In fact, I should see the blue marble any moment now from the starboard viewport. Wait, that's not Earth. There shouldn't be an orange planet anywhere in this sector. Unless, did we change course? Computer, is K7 at the helm?
Yes, Captain. He altered our bearings 4 months ago.
What? Why?
Reason unknown.
Computer, location.
Unknown.
Computer, patch me through directly to K7.
Access denied.
Computer, lock K7 out of the helm.
Access denied.
I'm so sorry, Captain, but K7 is mine. You and your crew are a necessary casualty for greatness. Thank you for the gift that you are giving to me. Goodbye, Captain.
Crew, hold on to something!
Warning.
We're going down!
Proximity alert. Imminent.
K7, do something!
Brace for surface impact.
K7!
Brace.
Emergency pull-up.
Welcome, ladies and gentlemen, to Escape from Planet Regex. Kotlin to the rescue. Well, the crew! Survivors! It's a miracle! Okay, we need to regroup together and formulate a plan. I, of course, am your captain of the USS Singleton, Captain Kadel. I am a senior mobile engineer for a company called Get Your Guide. Here are the things that I'm passionate about, and there's my socials. Now, back to business. The Federation emergency tablet dictates in a crash landing protocol we're to do the following. 1, we're going to learn about regex from the very basics all the way to the meaty advanced stuff. Then, we're going to learn about how you can use regex in Kotlin with the APIs provided efficiently. And finally, we're going to solve some puzzles with those two together. And of course, very finally, we're going to get ourselves off this barren, hot hellscape rock and launch a distress beacon. Thank you, Zach. Now, Federation protocol dictates as well that everything we see on this alien planet will be documented, very well documented. In fact, every video, link, article that you see here and many, many more will be in the link tree provided there, QR code on the screen, including the slides themselves. Now, one final thing. Our ship, assistant droid K7 was piloting when we went down, and I don't see him anywhere. I don't think he survived. K7, are you here?
Hello there.
K7! What the hell happened?
Captain, I cannot access my memory banks for the last few months. The entries seem to be corrupted.
K7, you were piloting us when we went down. You crashed us into this rock.
My systems seemed to reconnect seconds before the impact.
Well, what does that mean?
I attempted an emergency pull-up, but unfortunately, it was not effective as we were too close to the ground.
Yeah, I remember your voice over the comms in the very last seconds. K7, whatever you did, your maneuver saved a lot of lives. None of us would be here without you. Now what do we do? You hear that?
From the moment we entered the atmosphere, I detected strong signal interference on all of my communication modules.
Well, what is it?
I believe certain particulates in the air are responsible. Performing search, I have located only one match
One?
in the Federation database for this particle. It is called Regex, or better known as Zest Melange. Analyzing now.
Chapter headers, actual content incoming, goodness. So regex, or short for regular expressions, it derives from this mathematical concept of regular languages, which is a really boring way of basically trying to find patterns in language. Now, regex itself has been around since the prehistoric era and is very well established at this point. We can use a combination of weird and wacky characters to find patterns in text. Now, this is regex. You'll see this format throughout the slide deck. So the light gray box is our actual regex expression. It kind of looks terrifying. Weird, wacky characters in this order. Somehow that turns into a pattern. And of course, in the black box, we have our text input that we're testing our expression against. When we run our expression, we'll get some sort of matches, right? And I'll put color-coded on, like greens for matches, and the number of matches. You'll see it later. Anyway, regex is absolutely everywhere. Of course, it's in your CLI tools, your finds, your vims, your greps, etc. But even better, it's in most of the programming languages that we code with today. Most of them have some sort of regex capability. And even better, regex is somehow part of each of the IDEs and the tooling that we use to write our code. So having a good grasp of regex will really excel your experience. So let's start at the very basics, block by block, deciphering this weird, wacky chaos of regex. We're going to start with the very basic thing, literal characters. The very first thing you learn about is these boring things. It's letters and numbers, that's it. Letters and numbers, they help us ground our pattern in something that we know. They have no special meaning, they just mean the letter or the number. Here's our first example. In the gray box, we're looking for the letter B. So in our text, here are letters A, B, C. Regex will find the first and only occurrence of B. One match, boring. Here, we're looking for A, followed by B, followed by C. Luckily, we have those characters in that exact order, so we get one match. Collectively, the three characters together are the match. Of course, we can look for numbers, but what happens if we look for something that isn't there? So O followed by T is not there. O is, but O followed by T is not, so we don't get a match, and we get a fail. Of course, if we then look for O, something interesting happens. We find the first occurrence of O, but there's two O's. Why didn't we find the second one? We'll come back to that in just a second. But the real crux of regex is its special characters. This array of wacky, crazy characters that all have some sort of special ability, right? They do not mean they're literal characters. So a plus is not a plus, an asterisk is not an asterisk. They all have a superpower and do something weird. So let's look at one of these characters, the dot, which means wild card. Its special character is it can be any character you want, except for new line. Let's see some examples, it'll make more sense. Here I'm saying regex, find me the first occurrence of any character. So regex is like, yeah, the first character will do, capital H, see you later, way. Here I'm looking for the first three characters. Again, regex finds the first occurrence of any three characters, so the first three will do. Now we can and should anchor our patterns and our searches in bits that we know, so the literal characters that we know, and then obviously the wild characters that we're not sure of. Now, back to that O thing we talked about a second ago. Why did it only find the first O and not the second, right? This is by default's regex behavior. It will find the first occurrence of a pattern, not every occurrence. However, we can toggle this behavior using one of regex's flags. This is like regex's settings, and we can toggle this simply with the G flag, append that to the end. G means global, so hey regex, find me every instance of our pattern. And now, regex, of course, will find O and O, each individually one match, so two matches total. Here's the flags, and here's the useful ones. G, M, and I, we'll look at M and I in a little bit. You can combine the flags together at the end of your regex pattern to create whatever regex configuration it is you're trying to achieve. Just a quick note, those slashes in the pattern, they are nothing but a delimiter. They're just a way for us to say, hey, regex, this is the start of our pattern, regex, this is the end of our pattern, and this is the space where flags go. Okay? Not important. Our next special character is the weird backslash. Backslash is the only character that actually gets rid of a superpower. So whatever character comes after backslash, it will have its special ability nuked, taken out back, and shot. That was a bit dark. Anyway, so let's give an example. Imagine I'm actually trying to look for this period character, the full start there. I can't use dots because that's a wildcard character. It will find things that I was not intending to find. However, if I put a backslash in front of it, I do something called escaping it. I take that dot's power away, I turn it back into a useless dot, and now we can search for it. Cool. The next part is occurrence indicators. This helps us tell regex how many times we want to see something. So instead of me writing A, I can just be like, A, 6 times. Cool. And the first 3 characters you learn about is plus, asterisk, and question mark. Plus means, hey, whatever character came just before me, I want to see that at least 1 time or many, many times. Asterisk means, hey, the character that came just before me, I don't care if it's there, or it could be there a lot. You get me? Or the question mark character, which is the character that came before me, it's either there or it isn't there, 0 or 1. Let's see some examples, because I see people just passing out. So, A+, at least 1 A or many more. So regex finds all 3 A's together, 3 characters together are 1 match. Now, A+ here, of course, there's no A's. We needed at least 1. Hopefully that's self-explanatory. A asterisk. 0 A's or as many A's as possible. Again, we find all 3 A's. Boring examples. But A question mark was 0 or 1. So we've only found the first A. The others aren't interesting. And here, we haven't actually got an A in our text at all, but it's still a match. Because again, question mark is 0. It doesn't care if it's there or not, or it is. But the real side of occurrence indicators is being really precise about how many you want. And we use the curly brackets here in regex to say, hey, I want to see that 15 times. Or you give it a range between 3 and 6 times. You give regex a bit of choice. Again, let's see some examples. It's far easier that way. Here I'm saying, regex, I want exactly 2 A's, no more, no less. So it finds 2 A's, as you can imagine. Here, there's only 1 A. It's not enough A's. We needed 2, so it's a fail. Here's our first range. We're telling regex, I want to see either 1 A, 2 A's, or 3 A's. Inclusive. Our ranges are inclusive. And regex here has found all 3 A's. Why didn't it find just 1 A or 2 A's? And this is due to a concept called greediness, which we'll learn about in the next slide. You can also do sort of ambiguous ranges, where there's only 1 number defined in the range. Here we're telling regex, I want to see that A at least once, or many, many, many times. And hopefully, some of you are thinking, oh, we saw that earlier. That was the plus. And it just shows that the plus, asterisk, and question mark are essentially just syntax sugar for these kind of ranges. Cool. So over to that greedy thing we talked about. By default, again, default behavior, regex in occurrence indicators will be greedy. It will try and take as many matches as it can get. If it can get 3, it's by goddamn going to get 3. We can toggle that behavior by putting a question mark after our occurrence indicator. That turns it from greedy to lazy. And now regex will try and just take the least that it can get in order to make and satisfy a match. Oop. OK, next is anchors. And this helps us tell regex whereabouts it should find our match in relation to the line. So we've got 2 anchors, chevron, which is the start of our line, and $, which is the end of our line. These are our anchor points, and the examples will make this a little clearer. But there's one important flag, M, that we just shot past before that we're going to cover in just a second. So here's the anchors. Here I'm looking for the at the start of the line. Every the at the start of the line, there's only 1, so we find the at the start of the line. Here, I'm saying regex, it needs to be the word the, immediately followed by nothing, the end of the line. It must be the last thing, and so we get a match. Here, it's the at the very start of the line, but the word but is in the way there, so no match. It's got to be the very first thing. Now, here's the interesting one. This is the at the start of the line globally, right? And here, I've got 2 lines, both starting with the, but I've only got 1 match. Why is that? I'm glad you asked. It's because with regex's default behavior, it considers all of our input as 1 line. Doesn't matter how many new line characters are in there, it's like, that's 1 line, baby. So we can toggle that behavior with the missing M flag for multi-line, which says regex, hey, every time you see a new line, that is actually a new line. Give it a new set of anchor positional pairings. Cool. Next, we're blasting through. We've got to go. We're going to get off this planet. Character sets and ranges. Here we use the square brackets, and we basically give regex some options. Hey, regex, you can pick any one of these characters. Sets, we just give it individual characters, a collection of, and ranges, we say you can pick from A to Z or 3 to 5. Again, let's see some examples. Always examples. So first of all, this is regex A or B. So it will find the first occurrence of A or B, in this case, A. Now, A or B globally does exactly as you'd expect. It finds every occurrence of A or B, 6 matches. And of course, you can do something semi-useful like vowels, right? But the real powerful one, in my opinion, is ranges. We can put a little hyphen into our character set to make regex know you can pick from this character to this character. And it's clever enough to figure out, oh, lowercase letters from A to F inclusively. Here is numbers. You can just do numbers, so 3 to 6 inclusively. Now, this is an interesting one. Regex also differentiates between capitalized characters and lowercase characters. So here, I'm saying, regex, find me all capital letters. We haven't got a single capital letter there. They're all lowercase, but we've got a match. Why is that? It's our final missing flag, the I flag, for case insensitive. In that case, regex just goes, hey, a letter's a letter. You deal with that. And of course, you can combine your character sets and ranges into one big collection to give regex more choice to choose from. Now, the flip side of that. Negated character sets or ranges. Previously, we said, regex, you can pick one from these. Negated is, regex, you may not pick one from these. Anything but these. And to negate a character set, you just throw a chevron at the front of your range or set. Now, that is not the same chevron as it is for positional anchors. And this is why sometimes regex is a little bit tough, because some characters have slightly different meanings depending on the context. Over to alternation, right? We use the bar character here. We say, regex, you can pick from this pattern or this pattern. Well, hang on a second, Captain Kadel. Didn't we just do this or that? Well, yes, but we did it at a character level. So character sets and ranges let regex pick from X number of characters, 1, whereas alternation lets regex pick between 2 complete patterns. Useful. Let's see some examples. So here, we've got hat or cap. I'm really good with examples. So regex finds the first occurrence of hat or cap, hat, 1 match. Here's hat or cap globally. As you'd expect, it finds both 2 matches. Now, here is something interesting. I was trying to do something like, look at my hat, or look at my cap. But when I flip hat and cap around, it sort of breaks, and I just get cap. Because that bar, it doesn't care. It looks to the left, it's like, that's the whole pattern. And it looks to the right, that's the whole pattern. So instead, I was looking for look at my hat or cap. Hat, cap. Anyway, so to avoid that, we just throw some brackies. Throw some brackies around it. And now, as we'd expect, that works. And yes, I do have a whole course on how to make really, really bad examples for slides. Thank you for asking. Next is character classes. These are ace. They're just like nicknames or shorthands for things we've seen earlier. For example, slash, backslash, lowercase d would be any digit. So we've seen that before. 0 to 9, it's the exact same thing. They yield the same result. But the best thing about character classes is they often have a mirror opposite capitalized version. So slash uppercase d is any non-digit character, which in a pinch can be really, really useful. However, warning, not all regex engines support character classes. Most of them do. It's the 21st goddamn century. But just in case you're using a character class and you're like, why isn't this working? Then consider that. Now, on to the fabled capture groups. This is where we start to transition into the more intermediate advanced stuff. Capture groups are awesome. We use normal brackies for capture groups. And whatever is inside of the brackets, regex is like, I'm going to remember that. I'm going to keep track of that for later. Okay? Why is that useful? Well, this is really, really powerful when we use regex with programming, like you're going to see in a second. But once we've remembered something in a capture group, we can refer back to it later. Why is that useful? Again, glad you asked. You're asking some great questions, you lot. Let's see an example. Here's my regex pattern. In yellow, I have two capture groups. One that captures the name, and one that captures the age. So, Tom is 23 years old. Rest in peace, Tom. Sorry, all of you old people like me, they're like, oh, I remember Tom, I was friends with him. Okay, shut up, Ben. Anyway, what we've done, we've made a match. But we've also, in blue, made two capture groups. The first capture group contains whatever was in the bracket. So Tom, the name Tom. And we can now refer to Tom as \1. That's always how I like to refer to him. Now, the other capture group is the age \2. Why is that useful? Well, the next bit of the example, I've changed it a little bit so it fits on this the screen here, but my intention here is to basically do name, age, and make sure I get the exact same name again at the end. So Tom is 23 Tom, great, that's what I'm looking for, but with that pattern, Tom is 23 Dan would also work. Any other name would work in that space. That's not what I'm after. So instead, I can replace that with \1. And it's as though now I've sneakily sneaked the word Tom into the regex pattern. And now, Tom is 23 Dan will no longer work because it's looking for exactly Tom. Capture groups, yes.
Structural anomaly detected. I believe it is a ship.
It's a ship. We're saved.
Connection established.
Unforeseen circumstance. Zest melange interfering with communications.
K7, what the hell is that? That's the voice from the crash. Wait, have you been hijacked? Who are you? Who are you?
I'm your greatest nightmare. Kadel.
Ken Badell, the evil baron from Earth? What are you doing here? Wait, you're after the Zest.
Zest is the most powerful resource in the known universe. And now that I've finally found it, nothing's going to stand in my way.
Oh yeah? Well, me and my crew are going to stand in your way.
K7, destroy remaining crew members.
Uh-oh. Oh, okay, bringing lightsabers. That's cool. I can deal with that. Okay, 2 lightsabers. Oh, come on now. That's ridiculous. I have a better idea. Check this out. Pocket Zest. Yeah.
Captain, my sincerest apologies. I believe I am compromised and being remotely controlled.
K7, you're back. What the hell do we do? I think the Zest is only going to hold him off for so long.
There must be a foreign component within my circuitry.
Well, that's okay, because you are made of Kotlin, so we can pop you open, have a look, and fix you, using the world's greatest programming language. I goddamn hate that transition. So, the Kotlin of it all. It's all to do with this fabulous regex class that's provided by Kotlin's standard library. There's loads of documentation, boring, links, but I'm going to show you how to use it in a useful way. So we need to first instantiate this class. We can either do that via the constructor, passing in our regex as a string, or using the fabulous string extension function to regex. They're the same thing. They give you the same results. You can use them interchangeably. Just a quick side note over here. Strings, right, in regex, this string is maybe how you might do it in Kotlin, right, with just 2 quotes. And that is a legit piece of regex. \dot works, but the Kotlin programming language is like, yo, you're trying to escape something and shit's weird, bro, okay? So it steps in the way. So what you need to do is put // to escape the slash, and that's just kind of, yeah.
Brother,
Yeah, exactly. My feelings exactly. So instead, the top tip is to always use raw strings, which is just 3 quotes either side. And in that case, Kotlin's like, yo, that's a string. I don't care what's inside of it. Good luck. You got it. And you can write actual proper regex without having to worry about it. Great tip. Thanks, Ben. OK, back to the regex class. The flags. What about flags like I and M and G? Well, as part of the constructor or the extension function, you also can pass in regex options. And they are basically just a different way of calling flags. They're the same thing. You might see ignore case, multi-line. But some of you with a very keen eye will be like, hang on, where's the global flag? That was the really important one. There is no global flag. And you'll see why in about 30 seconds. Because let's have a look at some of the functions the regex class gives us. If we got them categorized, the first category is finds. Hey, regex, find this pattern in this text. The find function will find the first occurrence of that pattern, whereas the find all function will find every occurrence of that pattern. That's the global flag. We're doing it via functions, not a flag. Interesting. I think so. Matches, of course, is, hey, check that this pattern matches this text entirely at some point, or it contains something, blah, blah, blah. We can split strings by regex. That's fucking insane. That's awesome. And of course, we can do like finds and replace. Hey, find this pattern, replace it with this thing. And there's a load of other functions that I'll let you explore on your own. They're the main ones. But I'd like to draw your attention to the often used output, match result. What is that? Match result is Kotlin's encapsulation of a singular, regular expression having been triggered. The results. It's all contained in that object there. It contains this group, this collection of something called match groups. What the hell's a match group? Well, again, they just decided to change the name ever so slightly. You can kind of consider match groups as capture groups, kind of. Asterisk, kind of. Match groups, capture groups, kind of the same thing. You'll see why the asterisk right now. Because let's take a closer look. That collection, the first item in that collection, the 0 index, will always be the entire match, not capture groups, the entire match at the 0 index. However, every entry into that collection afterwards will map one-to-one to actual capture groups. So /1 will be index 1. And that's really useful to know, because otherwise you might get some weird, wacky results. However, there's this destructed parameter that gives you back your capture groups destructed, if you, of course, used capture groups, and it will omit the 0 entry that you're maybe not interested in. Let's see an example. Here's some Kotlin and regex for the first time. And this shit's terrifying to look at, right? But break it down. The first line is our pattern. We're instantiating a regex option. The next chunk is the text we're testing it against. So here, I'm aware the bits in yellow we haven't touched yet. We will touch them in a second. This regex is basically 2 capture groups trying to find a number followed by euros and a number followed by hours. We're doing like a salary thing. Here, we're using the destructed parameter to give back amount and hours, the contents of capture group 1 and capture group 2, and then doing some math with it. Maths. Now, if that made you poop your pants and run away, I'm sorry. I tried. Bless you, sir. Rest in peace. Then, of course, this code and all the other code you're about to see is in a repository, which is in the link tree. Please check that out in your own time calmly. Okay, K7, we're at the ship that you pointed out, but I've got some good news and bad news. Good news, we popped you open and found this illegal KB Industries communication chip, and we removed it. Bad news is we also found this. This location beaker sort of welded on to your nuclear battery, and we can't remove it without destroying you.
Does that mean that whilst I am functional, I am broadcasting the location of Planet Regex to Ken Kadel?
I'm afraid so, K7.
We cannot allow him to locate this planet and control the valuable zest.
I agree. We've got a plan, though. We'll get on that ship all together, including you, K7, fly us off this planet, and take back to the authorities this criminal and bring him to justice. Let's do that. I'm walking onto the alien ship. Acting. Whoa, alien ship that's conveniently placed here and looks pristine. Very cool, however. One more problem, crew. It's all in a weird gobbledygook language that I cannot decipher. However, some of you might recognize this input if, like me, you are a nerd and did Advent of Code last year, because this was day 3. And day 3 of Advent of Code asked us to take this big, long input and do 2 things. Part 1, straightforward. Find every mul with numbers in and multiply those numbers, add them all up. Fine. But part 2 has got really interesting. You should do the same as part 1. Find the muls, but only include them in our calculation if somewhere before the mul was a do with brackets and not a don't. Interesting. So let's do part 1 real fast. This is the code for part 1, right? Straightforward. We're looking for mul. Don't forget to escape your curly brackets. We're going to use the global flag. We're going to get a bunch of results here like this. And of course, we can make some sort of string utility function to split the numbers out, multiply it. We don't care about part 1. Part 2 is the really interesting bit. Because we know how to find muls. We just saw that. But how do we kind of like look around the mul to see if something came before it, sort of indefinitely? Well, this leads us on to one of regex's most complex topics, the idea of lookarounds, right? And there's two types. Lookaheads, which is, I'm on this piece of text now, I'm going to have just a little look, a look ahead at the text I'm about to read to make sure that something is there, positive, or to make sure that something isn't there, negative. And of course, we've got the same in the other direction, look behind. From the text I'm on now, have a little look from where I came from, and make sure that something is there, positive, or isn't there, negative. Now, it has some wacky-ass syntax that I always forget, but if ever you see a bracket and a question mark, you've probably got a lookaround. These are called zero-width assertions, which means they don't consume any of the search that we're doing. What the hell does that mean? Well, let's have an example to highlight that. Here we've got our salary example we had before. I've got two capture groups in blue, and inside of each capture group, there is a positive look ahead for either space euros or space hour or hours, okay? Let's run this like regex would and see what happens. First, we're going to hit the digit, any number of digits. I'm going to put that blue line there, by the way, to show that I've started a capture group. Then, whilst we're here, regex is going to just send out a little looker, a little scout. The little scout's going to go ahead and do the positive look ahead. It's going to make sure the next thing is exactly space euros. If it is, the scout comes back and reports, hey, it was there, cool. And the capture group closes successfully. But euros is not consumed. It's not part of the capture group. Ooh. Next, we have .star, and of course, that means any character, any amount of times, until we hit another digit. And again, we'll do this faster. The scout is sent out to make sure that space hour or space hours is there. And in this case, it is. The capture group closes successfully, not consuming hours. And that's the power of look-aheads, right? It checks that something was around it without taking it in. So that capture group doesn't contain the useless hours. It just contains the useful number. And euros was consumed, but it was only consumed by the .star and not the positive look-ahead. Let's have a few more examples. We're almost done, I promise. So here's some boring examples. Look-aheads, so looking ahead. We've got a positive and negative one. Here, I'm trying to say x should be followed by y and z. In the first case, it is. So x is a match, only x. Y and z, not consumed. We're going to do that together in a second. Remember, not consumed, okay? The other idea is look behinds. Here, I'm trying to say that z should be preceded by x and y, and it is. So z is a match, but x and y are not consumed. Well done, gold star, sir. Well done. See me after class. But then I got weird. You're like, no, Ben, you're never weird. And I thought, what happens if you put a look behind after the text? And this is what I was trying to achieve. I was trying to say that y should have x in front of it, which it does, but this is a fail. Why is that? Let's have a closer look. Let's run it like regex would run it. First, it finds the y. It's like, yeah, great, I found a y. Good. Moving on. The pointer of regex has shifted on, and now it's trying to perform a positive look behind. It's trying to say that x should be right where I came from. It sends out its little pointer, and it sees y, not x. And that is why it failed. Now, you can avoid that by adding in like a wild character here, or not doing that stupid shit in the first place. Cool. So part 2 can be solved as well with some wacky-ass regex. Now, this looks really terrifying. But again, let's break it down bit by bit. Now, logically, we're looking for do's, right? They're our sort of useful point. This is not, by the way, the best solution to this code problem. This was just an idiot trying to make a slideshow real quick before the deadline. So we're doing a do. We're looking for a do. And after the do, we're doing a negative look ahead to make sure there isn't a don't. But just that on its own wouldn't work. It would look only directly after the do. So we need this bit of fancy footwork. Another dot to consume the characters. So this is going to do, hey, no don't, consume, no don't, consume, no don't, greedily, over and over again, okay? Until, of course, it finds a don't. This bit of mull at the end is kind of superfluous. You'll see why in a second. But if we run that with the find all flag, we'll get some output like this. Multiple outputs of do, being the very start, a bunch of nonsense, and a bunch of mulls in there. There will not be a don't. Great job. And then, of course, we can take that and put it back into our, part 1 regex finder for moles and so on and so forth. Blah, 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 blah. Boring. But part 2 can be solved with some fancy regex footwork. Spin move. That was just for me. Thank you. Okay, crew, I think I understand regex and look-aheads and this crazy nonsense, so let's try turning the ship on. Beep, boop, beep. I think it's working. I think it's working. Oh,
My diagnostics indicate that the ship's battery is entirely depleted.
of course it is. What the hell did we do?
It requires jump-starting with an extremely powerful alternate power source.
And where are we going to find one of those, K7?
I know where.
You know where? Where? K7, don't walk away from me. What are you doing? K7?
I, Captain, am the alternative power source. My compromised battery, to be precise.
Okay. How would that work and why are you stood outside?
I can transfer the remaining voltage to the ship. Not only would the ship be able to take off, but the process would result in my exploding.
What?
Along with the location beacon.
No. K7, you're not going to explode for the ship. Come back inside, we'll figure something else out.
Thus stopping Ken Kadel from locating Planet Regex.
K7, we will find another way. It's an order. Get back on the ship.
Thank you, Captain. It has been an honor serving by your side.
K7, don't do this. K7, come back. K7! K7! He did it. K7 sacrificed himself for us, for you, for the ship, for Earth, for Regex. We'll never forget you, brother. Thank you. Thank you so much for coming to my ridiculous goddamn talk. I love this stuff. There's my socials on screen if you want to pester me or be like, yo, that was garbage. I can't believe I wasted 45 minutes. Links, of course, to everything I talked about and more. I really would recommend going to the and more bit because there's like awesome little daily regex problems and stuff and other little cool tools I found. And of course, I'm one of those assholes that has my very own branded merch. So I have a couple of Ben Kadel stickers, a couple of Ken Kadel stickers, boosts. I've got some pins, and I've got last year's Refi stickers, in case any of you saw that and wanted a sticker and didn't get one. And of course, this year's very limited edition K7 stickers. Rest in peace, buddy. So if you want any of that stuff, find me. I'll be around, probably sprinting out of this hall into the fresh air. Thank you all so much for your time. Have a great rest of DroidCon New York.